Today I'm going to start with exercise 8.4. The first question reads as express the trigonometric ratios sine A, the question number 1. So sine A, secant of A, and tan A in terms of cot A. So this is what is the question. So we have to express sine A, secant of A and tan A in terms of cot A. So first of all, we know that tan A. So I want to begin with tan A. Tan A is nothing but tan A is nothing but 1 by cot. This is a basic definition. So this is simple. So now sine A. How we are going to express sine A in terms of cot? So we know the identity. 1 plus cot square A is equal to cosecant square A. And similarly, we know that cosecant is equal to 1 by sine. So I can write like this. Sine square A is equal to 1 by cot 1 by 1 plus cot square A. So I think this step is have been clear because cosec is 1 by sine. So 1 by sine square is equal to 1 plus cot square A. So if I take the inverse, it will be 1 by 1 plus cot square A. So now again taking the square root, I can write sine A is equivalent to 1 by square root of 1 plus cot square A. So this there are only cot terms here, only cotangent terms. So this is what they have been asking. And next one is secant. How will express secant in terms of cot? So now I am going to begin with one more identity, that is 1 plus tan square A is equal to secant square A. So these identities are very important. These three identities, sine square A plus cos square A is equal to 1 and 1 plus tan square A is equal to secant square A and 1 plus cot square A is equal to cosecant square A. So now we know that tan is equal to 1 by cot A. So I will substitute it again here. So 1 by cot square A equal to secant square. So now I will simplify this expression. I will take the LCM. So cot square A plus 1 divided by cot square A is equal to secant square A. So I hope this up to here it is very clear. So now I want to take the square root on both sides. So secant of A is equal to root of 1 plus cot square A by cot A. So again, you may ask me why I am considering only the positive root, because if you know that for a quadratic equation there are two roots, plus or minus root will come, but I am not considering the negative case. Is there negative case because we are considering angle between only 0 to 90 degree. We are considering only angles between 0 to 90 degree, and every trigonometric ratio is positive, that is either 0 or greater than or equal to 0. So their value is greater than or equal to 0. So we are only considering the positive root. Here we are not taking a negative root. And this is the first question. So I am going to start with the second question now. So question number 2 is again this, it is similar question, like express the other trigonometric ratios of angle A in terms of secant of A. So now we have to express, first I will begin with sine A. Sine A in terms of secant, we need to express in terms of secant of A. So how I am going to start here? So I can say that sine A is nothing but 1 plus 1 plus tan square A is equal to secant square A. Using this identity, what we can do is 1 plus sine square or is there one more method like this that I don't want to complicate by going this way. It is much simpler method is there than this using this identity. So you can do this, but this is quite complex. So you may try doing it that way, but I am going to do in a different manner. Consider that we know that tan theta. What is tan theta? Let us see what is tan theta. Tan theta is nothing but sine theta by cos theta. So I can write it as sine theta into 1 by cos theta. So now you know that what is 1 by cos theta. This 1 by cos theta is nothing but secant. So sine theta into secant of theta. So we can write tan theta in form of secant theta as like the sine theta into secant theta. So now I will use the same expression 1 plus, now using the identity tan square theta is equal to secant square, because we don't want the cos term in the denominator, so directly I can use it. So it will be nothing but 1 plus sine square theta into secant square theta is equal to secant square theta. So now I bringing the like terms together, secant square theta minus sine square theta secant square theta is equal to 1. So I am taking essentially this one this side. So now if I take sec square common out, this will give nothing but 1 minus sine square. Yeah, sorry, I should express in terms of secant. So this should be the other way around. So I have to take 1 that side. So if I take 1 that side, what will happen? So this will be sine square theta into secant square theta is equal to secant square theta minus 1. So now sine square theta is equal to sine square theta is equal to secant square theta minus 1 divided by secant square. So now again I am taking the square roots on both sides. I will get it as sine theta is equal to root of sec square theta minus 1 by secant of theta. So this is a sign in terms of secant square, sec theta. I hope it is clear. Similarly, I can do it for cos and also for tan. Let us try doing it. So if I take cos, so now I will take cos of theta. How I am going to express it in terms of, so again I will start with the same expression, 1 plus tan square, 1 plus, this time I will take it as tan square, again tan square. So tan square is equal to secant square, 1 plus tan square is secant square theta. So again I can write tan theta as, again now in terms of cos I have to write. So this is nothing but tan theta is equal to sine theta by cos theta. So this is sine theta into secant of theta. But now again this process is not required. You may be already guessed it, right? Because I am just trying to say that without using these all things, we can directly, we know the result that cos theta is equal to 1 by secant theta. So you can try doing this or any other method using another identity, but I am not going to do it. So this is left to be as a task, you can do it, but this is little foolishness to do like this. So I can directly write the result as cos in form of sec. So cos of A is equal to secant of A. So there now I am perhaps you may have got confused like why theta and A I am using in interchangeable manner, like I feel comfortable with using theta instead of A, so I am using it theta here. So I am going to continue with the other angle, that is tan now. Now I am going to write with respect to tan. How? Third one, consider tan theta. So for example, in terms of secant I have to write. So this is pretty simple. We have to write identity 1 plus tan square theta is equal to secant square theta. Now taking this one that to the right hand side, so tan square theta is equal to secant square theta minus 1. Similarly tan theta is equal to, so square root of the right hand side, secant square minus 1. So this is the tan theta in terms of secant. So now I am going to write cos, similarly cot theta. Now you know that cot is 1 by tan. Cot is 1 by tan, so cot theta I can write directly as 1 by square root of secant square theta minus 1. So this is there, and also I can write cosecant. Cosecant is 1 by sine. So if you remember the expression of sine, what the expression of sine turned out to be secant square theta minus 1 by secant square. So I will reverse it. This is nothing but secant theta by square root of so if I take square root, this one, so this should be be there. So similarly, I can write for that's all. So these are all I have written for sine, cos, tan, cot, and cosec. So all are there. So this is what this is expressing in terms of secant theta. All other angles in terms of secant theta. So similarly, you can try doing for other angles also. Express everything in terms of tan or cos. These things you may try as an exercise, because it will be very helpful, sometimes very handy also. So I am going to start with the third question. Third question is question number 3. So it is given as sine square 63 plus sine square 27. Obviously it is in degrees, 27 degrees divided by cos square 17 plus cos square 73. So now in a revision video I have discussed that complementary angle property, that is I can write sine 90 minus theta is equal to cos theta, and similarly I can write cos 90 minus theta. These are all degrees. So 90 degree minus theta, it is not 0 theta, is equal to sine theta. So I hope using this property I can see you can see that I can write sine in terms of cos. So similarly writing it, you can write anything. It will be, now I will take the first expression. I will take it as, so sine 63 is nothing but equal to cos 90 minus 63. So this is equivalent to cos 27 degree. So squaring it, I can write numerator as cos square 27. Similarly, denominator I can consider cos 73 degree is nothing but sine 90 minus 73 degree. That gives me, which is equivalent to sine of 17 degree. So I will substitute this in numerator and denominator, the values. So I will get the expression as cos square 27 degree plus sine square 27 degree divided by cos square 17 degree plus sine square 17 degree, which is nothing but, now you remember the identity. The identity states that cos square theta plus sine square theta is equal to 1. Whatever the angle may be, since both angles are same 27 degree, this identity is equal to 1. And denominator also both angles are same, cos square plus sine square theta is equal to 1. So answer is 1 here. Similarly, if I go for B part, that is, this is a 3-1 first question, and also I can go for second part also. If I go for second part, then this is also similar manner. We can solve it in a similar manner. Like the question is sine 25 degree into cos 65 degree plus cos 25 degree into sine 65 degree. Again, using the same complementary angle property, I can write, you can write in any way. I'll write it as sine 25 is equal to cos of 90 minus 25. That is nothing but cos of 65. Similarly, I can write right hand side here. I can write right hand side as cos 25. Now cos 25 is equal to sine of 90 minus 25, which is equivalent to sine of 65. So if I substitute this in the above question, so what will happen? Sine, instead of sine 25, I'll write cos 65 into cos 65 degree plus, instead of cos 25, I'll put sine 65 into sine 65. So if I do in this manner, we can very clearly observe that this is cos square 65 degree plus sine square 65. Again it is using this identity, cos square theta plus sine square. This is the most important identity among all. Like there are three identities, but this is equal to 1. So this is the most important. It is important in other classes also, upcoming 11th or 12th. So this is equivalent to 1. So these are very simple problems, but a thing is we have to think in a proper manner where to use which one, which identity. Once you get familiar with using this way, then it will be very simpler. Any question you can solve. And let us solve many questions, and I'll continue with the next next set of questions in a next video.